Hello, and welcome to another session of Live with Andrew. And even though this is just a recording that is on our YouTube page, it is recorded live. I am a live person here talking to you. This is Fractions on May 14th, 2020. And this is our lesson 6 of the live math series. And today we're going to be talking about fractions, but we're really going to be emphasizing the reducing and equivalent fractions. And we're going to get into the first part of it, addition and adding of fractions. And then there'll be a following lesson coming up on subtraction and more advanced fractions, and then multiplying, dividing, and all that will follow. As we go through, again, follow us on Facebook, hit subscribe on the YouTube channel here. We want to make sure that you're able to access us from home, and you'll be able to keep doing all the things that you have been doing in class, whether it's Essential Ed, KET, all those kind of things. We want to make sure that you have access to that. You are still doing the different programs, because sooner than later we will start testing again. We don't know exactly when, but when we start testing, we want you to be ready to hit the ground running. There's some good ideas and options coming out about that, and a lot of that will come from students that are ready. So we want to just make sure you are ready when we begin. If you have any questions about your login information or any of that, please contact your teacher through Remind, or as always, you can email adult.education@rcsd.ms, and we will be more than glad to assist you in this process. Again, I use this every time. I cannot emphasize the importance of Khan Academy. It is a great way to get practice on these skills. A lot of the skills that we're looking on now and will be doing are skills that you learned really in second, third, fourth grade. And it's important skills you need to know on the test. And you may say, well, I'm a dummy. I don't know how to do third grade math. No, 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 no. You're not. You just haven't used it in a while. All right. And that's why it's important for us to go back and do these refreshers and to go back and say, okay, how do I do this? Once you start doing it, you'll start to remember the skills and things that go on. A lot of this math you learned years ago, and depending on how many years removed you are from it, is where there may be more deficits that you need to fill in. So go to Khan Academy, join our class. We'll be more than glad to help you out with that. As you're going through, also know that Smart Start is available. It's online. If you have any questions, just email me, or you can leave a comment and we can get you signed up for it. It is a great way to learn job skills for the world we're in today. The workforce is starting to bump back up. People are starting to work more and more as the social distancing is starting to wane a little bit. There's going to be positions available, and it's going to go to the best qualified people. And there's ways to learn how to make yourself more attractive to employers. If you have questions about that, again, ask your teachers, ask me, and we will be more than glad to help you out with that. So we are looking now at a go back lesson. This is something that is not going to follow that same progression of what we've been doing, but we're going to go back to fill in some of the gaps that you might have had from some of the work. Now, if you say, oh, I'm above this, I don't need it, well, okay, then you can skip this video. But it's a good idea to go back and review to make sure you know this well. These are skills that are on the test. You need to know how to do these skills. You need to know how to do what we're talking about, because it comes in play in a lot of different areas. And I'll be talking about that over the next couple of lessons, how it does. We're talking about fractions today. And 5 out of 4 people have trouble with fractions. This is a little joke that I've seen multiple times. I even had a little magnet somebody had given me years ago that hung in my classroom for a long time that said this. Fractions are something we use often, but a lot of times we mess them up. My son just the other day said something about he was 3/4 of the way through a book he was reading, and then maybe another half after that. And I was trying to see what he was talking about and had to help him kind of explain it. And he was getting really confused. Now, he is a 4th grade and he's just learning fractions. But fractions are something that we use when we cook, and we're pretty good with it until we have to half, or we need to double a recipe, or for some reason we can't find the 1/3 and we need to make a third, but all we have is a quarter cup and we have a half cup and we don't have that third of a cup and we don't know what we need to do with that. So there's a lot of different things that people run into with those kind of things in fractions. And we're going to look at it today and see how can we learn to do a little bit more with fractions. As with the basic operations that we talked about before, fractions again are a crucial concept that's important for you to know. So what do you need to know about fractions? And this is where it kind of comes down to it. How do we need to know what fractions are? And a lot of it is just going to start from looking at a fractional part. Here we have 3/4. We have the 3, we have the line, we have a 4. And what are those parts? That's the thing that we have to look at and try to see, okay, well, I know it's a numer something, and I can't remember. Well, a good way to remember this, the terms are, and you need to know what the terms are because it's important when you're doing math to have precise language. We don't want to just call it the top number and bottom number. We need to call them by what their names are. And there's the numerator and there's also the denominator. The numerator is the one that's on top. The denominator is the one that's on bottom. How can you remember these? There's a lot of little tricks I've heard people use through the years. One of the best that I heard is another teacher, Miss Jill that I used to work with. She taught me this a long time ago, and it's a good way to remember it, and it can help you kind of see. So here's one little trick to remember. The numerator that's on top is numerator. It has the NU are the first two parts. So NU, and then if you look at the next one, the denominator is DE. So you have numerator, denominator, and that spells the word nude. So when you see that, it's silly, it's childish, I know, but when you see that, it kind of helps you to think, oh, hey, censored, we got nude numbers, but that helps you to kind of remember where those are. NUDE, numerators on top, denominators on bottom. So you can see nude there, and it kind of helps it put in place. If you put it DENU, denu, or denu, doesn't spell anything, but nude kind of helps you to remember there. So that's a little trick to kind of remember the numerators on top, the denominators on bottom. Now, the next part of fractions that you need to know, that fractions are part of a whole. Whenever we see a fraction, it means we have a fractional part of something bigger. So in this particular fraction, we see 3/4. That means we have 3 out of 4 parts. And that's a key thing to look at. If you see the picture there, you see there are 4 squares, and well, one big square, and there's 3 black squares and then a gray square. We have 3 black squares out of 4 possible squares. And that's what a fraction is. We're saying that there's 3/4 of the whole, whatever that whole might be. This could be pizza, this could be cake, this could be a chocolate bar, it could be a piece of wood, it could be a lot of different things. So we're just looking at a fractional part. It's less than a whole right now. When we see this, we see just the fraction. Anytime you see just the fraction like this, as long as the numerator is smaller than the denominator, then that fraction represents something less than the whole. And it's just being part of the whole. Now, we talked about operations last week, and as we're looking at this and we're thinking about, okay, how does this kind of relate to what we've talked about in the past? Well, you see here, we have part and whole. We know that that's there, but that 3/4 looks familiar. And as we go to this next slide, that 3/4 looks a lot like division. This is a division problem like those basic operations. Now, we talked about the part and the whole. The whole makes up all of it. The parts, the portion that we were talking about, that's what a division problem is. It's dividing the bottom, the denominator, into the numerator will give you what that fractional portion is. Now, we're going to talk more about this in the next few weeks. As I do some of these lessons, there'll be a lesson on decimals. Fractions and decimals walk hand in hand. They are brother and sister, and it's going to be important for us to see how those fractions and decimals work together. That's one of the things I know on the GED test. You have to be able to look at and order fractions and decimals. Be able to know is 3/4 bigger than half, or bigger than 5/10? Or what about 67 hundredths? Is that bigger or smaller than 3/4? You've got to be able to look at fractions and decimals and see it all together there. And we'll talk about that more in the weeks to come. But as you see here, it's a division problem. We see a fractional part and it's division. And if you think about it, on the square that we have there with the 3 black squares and the 1 gray square, we've divided that square into pieces. How many pieces did we divide it into? Well, we divided the square into 4 pieces, and we've darkened in 3 of them. So 3 out of the 4 squares are darkened. So that helps you to kind of see how we're dividing it up. Now, a lot of times we think of division as just purely, oh, we're dividing a number. Well, yeah, but let's think about dividing a shape. If we just split the shape up into pieces, that's what division is. It's a good graphical way to explain a concept that we're all familiar with there. All right, so fractions are division problems. Going back to our first lesson in our live series, the basic operations are crucial. You have to know how to multiply, divide, add, and subtract. And we're going to see that a lot as we go through what we're doing today. All right, now, I mentioned it just now. Division is hand in hand with multiplication. Multiplication is an important skill for everything you're going to do in math. Everything kind of goes back to these multiplication tables that you see. And as we look at this, this is actually shows you a lot of fractions. And I could split this up in a lot of different ways, but we're going to stick with the 3/4 section. So if we look at this and we see this multiplication table, and it's just your typical table, it goes down to 6, it goes across to 9, and those are all the different multiplication factors on there. But I'm going to zoom in just on the 3/4 section. So if you look at this, we see 3/4 are 3/4, and then all the way across here, those are fractions. 3/4, 6/8, 9/12, 12/16, 15/20, 18/24, 21/28, 24/32, and 27/36. Those are all fractions. And we're going to see how these fractions are what we call equal fractions. Now, all these fractions all the way across, they're equivalent because they both have the root of 3 and 4 in this particular thing. We're just multiplying each fraction by the numbers that are going across the top there. So 3/4, we multiplied it by 1, and that gives us 3/4. On the second one, we're multiplying, and it's not just one part. We're multiplying both numbers. We multiply the 3 by 2, we multiply the 4 by 2, and that gives us 6/8. We multiply both of them by 3. That gives us 3 times 3 is 9, 3 times 4 is 12. And we're going to see more about that as we go through this lesson. But what we're looking at here, these are what we call equivalent fractions. And I mentioned that a second ago. And this is, if you're jotting notes down, I know a lot of students like to write little notebooks and put notes on their paper. It's important for you to take some of these notes, and this is a good one to write down. Equivalent fraction means equal fraction. We talk about high school equivalency. You earn your GED, you earn your high school equivalency. By getting that equivalency, it's saying it is equal to high school. It's the same thing, it's equivalent. And that's what these fractions are. Just from the chart that I just showed you, we have 3/4. What that's saying is 3/4 is equal to 6/8. And 6/8 is equal to 9/12. You may say, are you stupid? No, they're not equal. They don't look equal, but they are equal because everything is multiplying up by the same thing. Everything is following the same pattern. And we'll see kind of how that works as we move forward. But it's important for you to understand what equivalent fractions are. You're going to have to use this in a lot of different places in math. You're going to use that when you're adding fractions, when you're multiplying fractions. You might have to use some of these skills. Reducing fractions, when you get into ratios and rates, You'll have to use some of these same things. It's very important that we learn how to do these proportional problems like this and understand how those fractions work. All right, so as we move forward and look at this, we have here, we're not changing what the fraction is, we're just changing what the fraction looks like. So as you see here, we have 3/4. And in the picture that I have on there, it's the same one we've been using the whole lesson so far. There's 4 squares, 3 of them are blackened and 1 is gray. All right, so we have 3 out of 4 squares. Now to make it equivalent to the 12/16, we are multiplying it. We're taking that same 3/4 and we're putting it up there 4 times. So you can see there are, I just took the squares and I just copied them on there 4 times. The top corner, there's 3 black ones and 1 gray. In the top right corner, there's 3 black squares and 1 gray. The bottom left corner, there's 3 black squares, 1 gray, and then there's 3 black squares and 1 gray in the bottom right. So you see all those, it's just the same thing. Now, all I'm going to do is just rearrange where those are. So as I rearrange them, you see there are 3 groups of 4 that are black, and there's 1 group of 4 that is gray. So on here, if you kind of realize that's just a bigger version of what we see, we've just split up each of those squares into 4 pieces. So in the first one, we had 3 black squares. We split those into 4 pieces. 3 times 4 gives us 12 black squares. And then how many squares were there all together? There were 16 squares in the bigger one because we multiplied 4 times 4. And that gave us that same proportional thing. Now, this is equivalency. We're looking at high school, or not high school equivalency, but fractional equivalence. And we're looking at equivalent fractions there. But what we're doing here is just finding what's the proportional adjustment. This is a ratio, this is a skill, it's following the same thing. You're going to do this often in the GED. You're going to do this on the HiSET test. You're going to have to do this on the TABE test. You need to understand how these these relationships work and the proportional relationships that you see here. Now, what we're doing, I've just described it. Here's it just written by. When we multiply 3/4 by 4/4, it doesn't change what the fraction is. It just changes what the fraction looks like. So 3/4 times 4/4 gives us 12/16. We multiplied 3/4 by 4/4. Now, you may say, why didn't you just put times 4? When we get into multiplication, you'll know you can't just put times 4. It has to be 4/4. And we'll talk about that at a later time, exactly why that is. But it's important for you to understand, anytime you see a fraction over itself, like in the middle there, we see 4/4, what that really means is any number over itself equals 1. So we're just multiplying 3/4 by 1, and it equals 12/16. So we're not changing what the number is, we're just changing what the number looks like. So we're not changing 3/4, we're just changing what 3/4 looks like. The best example I have, and I should have put this on a slide to illustrate it for you, if you give me $1 and I give you 4 quarters, I'm not changing how much money you have. I'm just changing how much money you have, what it looks like. You still have $1, but instead of having 1 solid dollar, now you have 4 coins out of 4 coins that make the dollar. So you have 4 out of 4. That's where the dollar comes from. So I'm changing, again, what it looks like. That is what you're doing here. So as we think about it, if you put any number over itself, 1,000,000 over 1,000,000 equals 1. 5/5 equals 1. 2/2 equals 1. 100 over 100 equals 1. Any number over itself equals 1. And you can see this is what changes those numbers. So let's look at another example. All right. Well, actually, let's not look at an example. Let's work it backwards. Let's do this backwards. If we reduce the fraction, we can reduce it back down to 3/4. And you may say, well, how do we do that? Remember, the opposite of division is multiplication. The opposite of multiplication is division. So if I say 15 over 20, and I'm going to divide it by something over itself, what's a number that goes into both 15 and 20? Well, 15, we have 1 goes into 15, 3 goes into 15 5 times, or 5 goes into 15, or 15 goes into 15. So those are the options I have. Well, when I look at 20, okay, 1 goes into it, but that won't really help us. 2 goes into it, but 2 doesn't go into 15. 3 goes into 15, but doesn't go into 20. 4 goes into 20, but not 15. 5, it goes into both of those. And because we see it ends in 5, it ends in 0, we knew automatically that they both could have 5 go into it. So if we divide both of those by 5, so 5 over 5, 15 divided by 5 is 3, and 20 divided by 5 is 4. So that reduces 15/20 down to 3/4. So whether we're working up and finding it or working back to reduce it, this gives you a chance to see how that works. You just see what's something that will go into both of those. All right, so let's look at the next slide. Take a few minutes, and y'all are all watching this on YouTube, so you'll just be able to pause once I give the instructions. And I want you to come up with 3 equivalent fractions for each problem below. I give you the number. I just have it written there 3 different times. I did that so I could show you and work them out once we're done. But go ahead and try to make an equivalent fraction. So you're just going to multiply each one by the number. Whatever you multiply the bottom by, multiply the top one by. And do that for each one of them. Take a few minutes, pause it. When you're done, you can hit unpause, and I will go over the explanations with you. All right, now you've had a chance to work those, so let's look at them. Okay, so on the first one, and I'm just going to give a few examples of how to do each of these. It may not have been the examples you use, but you can see if these are what works there. So we're going to multiply both of them by the same thing. So the first one, I just chose 4 over 4. 2 times 4 equals 8. 3 times 4 equals 12. So 8/12 is an equivalent fraction. Another one that I could have done, and I'm going down on these because that's the way that I happen to animate it. We just multiply the next one by 2 over 2. I just picked a random number, and 1 times 2 equals 2, and 5 times 2 equals 10. So 2/10 is an equivalent fraction to 1/5. For 5, 6, you're going to multiply both of them by 2 over 2. Again, 2 over 2 equals 1. 5 times 2 is 10. And 6 times 2 is 12. So 10/12 is equal to 5, 6. Then as you can see, and I'm just going to kind of click them as we go through, I chose 5 over 5. That gave me 10/15. I chose 6 over 6. That gave me 6/30. Big number, but still it equals 1/5. Then I have 5, 6. I chose 5 over 5 for that one. That will be 25 over 30. Then my last examples here, I chose 7 over 7. That gives me 14/21 or 20 over 21. I have 1/5 times 10 over 10. It's just 10 over 50. And then the last one for 5, 6, I chose number 9, or the number 9, 9 over 9 equals 45 times 9, or 5 times 9 is 45, and 6 times 9 equals 30. All right, so you see those? You see how the problems are there? I gave you some examples of how you could reduce those, or not reduce, make those equivalent. Now, if hopefully you got those. If you didn't, just you can see the process there. If you need to pause it and look at them to see if you got something wrong. Most of the time when people get these wrong, it's because they make calculation errors. They just, oh, wow, I multiplied that wrong. That's why it's so important to know what your times tables are and to make sure you're familiar with those. All right, so let's look at the next one here. Take a few minutes to reduce these fractions to the lowest form. Now, I have them on here. There's 9 different problems. You're reducing it to the lowest form. And the reason I say the lowest form, you might reduce it by something and then have to reduce it again. We want to get it to where it has nothing else that can go into it. A lot of times, if you're not sure, use a smaller number, and you might have to reduce it more often, 2, 3, something like that. It might just get you there, but it might take a couple of times to reduce it. The bigger the number that can go into both of the numbers there, the numerator and the denominator, that's going to reduce it quicker for you. You don't always have to do the big one. Sometimes I choose to use a smaller number just to make it easier. I just put what goes into it. Other times I remember a bigger number that might reduce it, and it makes it a little bit easier. All right, so take a few minutes, pause this. You can work these out, and then when we're done, I will work them all out for you. All right, that was a lot. I know there were nine problems there. I wanted to make sure on these lessons you had ample practice to do some of the problems. So let's look at them. The first one there, 27/30. So what are we going to reduce that by? We're going to divide it by, and I just chose 3 over 3, because 3 over 3 equals 1. 27 divided by 3 equals 9, and 30 divided by 3 equals 10. So that reduces that down to 3 over 3 equals it 9/10. All right, so we divided that one by that. All right, on the next one, I'm just going straight across on this one. 8 and 12, I divided it by 4 over 4. When I have 4 over 4, what does that reduce it to? That reduces it to 2/3. 8 divided by 4 is 2. 12 divided by 4 is 3. All right. On the next one, 25/75. A lot of people might just think, oh, well, let me put 5 into both of these. Okay, yeah, you could use 5, and that would give you 5 goes into 25 5 times, 5 goes into 75 15 times, but then you would have to reduce 5 over 15. I chose the largest number you could use, which is 25. 25 goes into 75 3 times, and 25 goes into 25 1 time. So that reduces down to 1/3. On that one, think about quarters. If you have 3 quarters, 25 cents is 1/4 out of 3 quarters, and that's where that comes from. All right, so the next row, 9/18. We divide each of those by 9. 9 goes into 9 once, 9 goes into 18 twice, so that is half. Again, if you look at that and you go, oh, 9 is half of 18. Yeah, you'll start to see, like I've talked about before with the multiplication tables and stuff, you're going to start to see connections with numbers. You're going to start to see relationships that numbers have together. When you see 9/18, you should instantly know half. When I showed you the multiplication chart of 3 over 4, and then 6 over 8, and then 9 over the next number, 3, 6, 9, 12, those connections that you have there, you'll start seeing those numbers together, and you'll know, oh, that's 3/4 every time. All right, so it's important to look at that. All right, the next one's 16/24. We're going to divide each of those by 8. 8 goes into 16 2 times. 8 goes into 24 3 times. So there's another 2/3. When you look at 15/60, we divide each of those by 15. You might not have caught that one. You might have thought 5 first and then had to reduce it again. But if you do 15, it does it the quickest. 15/15 is 1. 15 goes into 15 once. 15 goes into 64 times. The last column there, we have 26 and 28. 2/2, it equals 13/14. For 25 and 100, what goes in each of those? Again, 25 goes into both of those 1 time and 4 times. So that's 1/4. And then the last one, 12/36. This one you might have been able to just see and know, or you might have had to break it down into a couple parts. But 12 is your largest number you could put in there, and that gives you 1/3. All right, so hopefully you have those. If you need to pause it, look at those, check your work to see if you didn't choose those numbers, you did it differently, you should end up with the right number eventually. So on a few of those, if you didn't reduce it enough, you might have to take it a step further. But those would be your correct answers to reduce those down to the lowest form. Now, as we're going forward, we've made equivalent fractions and we've reduced fractions. But now let's add and subtract fractions. And I created this slide before I finished the whole presentation. We're actually not going to subtract yet. That's going to be a to be continued. We're just going to be working on adding fractions first. But let's go ahead and start that next part here. To add fractions, you must have a common denominator. What is common denominator? Common means same, and denominator means bottom number. We talked about that before. All right, so we have to have the same bottom number. So 2/7 plus 4/7, we can look at those and say, okay, do they have a common denominator? Do they have a same bottom number? Yes, they do. So now I look at that and I can just say, well, 2 plus 4 is 6. I just add it straight across the top. The bottom number, though, if you notice, I don't add the bottom number. All I do is bring it across because that's how many pieces make a whole. And the whole's not going to change. I have 2 out of 7. I have 4 out of 7. That equals 6 out of 7. All right, so as I do this slide and you see that going across, I get to 6/7. Is there anything I can divide it by? No. Nothing goes into both 6 and 7, so it's reduced to its lowest form, and it's 6/7. All right, now, you may say, well, why did you divide it? I mean, I could already tell 6/7 was the lowest form. I want you to start getting the practice of that because on some of these, you will have to reduce. All right, so we want to make sure that we're looking at it to see if that will happen that way. Certain numbers you'll notice as denominators are going to reduce more often than others. Odd denominators don't reduce nearly as often as even denominators, just because there's more numbers that can go into it, especially 2 if you have a lot of even numbers there. So let's look at the next one. We have 1/4 plus 1/4. Okay, does it have a common denominator? Yes, it does. So I can add those two fractions. I add the top number and bring the bottom number over. That's going to be 2/4. And then on this one, I'm going to divide. What am I going to divide by? Because I can reduce 2/4. There's a number that goes into both 2 and goes into 4. That number is 2. So I divide it by 2/2, which gives me 1/2. And we could see that again. And a lot of times it's once you reduce it, you go back and go, oh yeah, of course, 2 is half of 4. And you're able to see it right then and answer it. Okay, so let's look at the next one. 1/5 plus 1/5 plus 1/5. Okay, can we add these? Again, I have the rule still written at the top. To add fractions, you must have a common denominator. Is the denominator the same? Yes, it is. It's 5 all the way across. So 1 plus 1 plus 1. I'm going to add that up all the way across and see. So 1 plus 1 plus 1 is 3. 5 comes across. Can I divide that by anything? Nope, I can't divide it. So 3/5 is my final answer for that one. All right, so those have all had the same common denominator. So now let's look and see what would we do if the denominator was different. Now, if you notice here, I wrote it in a different way. And the reason why, when you go to do these, it's good to have them written vertically this way instead of horizontally. And you'll see why as we do the next step. So if this problem was written the other way, all you'd have to do is just rewrite it this way. And I tell people all the time, rewrite it. If you try to do it in your head, you try to do steps, it kind of messes you up. I like to do it this way because it's the same way we did it a few slides ago as you see what we're going to have to do. Okay, so the rule at the top of the page there, to add fractions, you must have a common denominator. 1/4, 1/3, that's not common. They're both different. So what do we need to do to make them common? We need to find what is an equivalent fraction for each of these fractions that will be the same fraction. So it'll be a common denominator. So what I look at 4 and I look at 3 and I go, well, what do 4 and 3 have in common? If we were multiplying them out, 3, 6, 9, 12. Ooh, 4 goes into 12 because 4, 8, 12. I know both of those are in common. So what I will do, I will multiply each of those fractions by what it takes to make it have that equivalent denominator, which happens to be 12. So for the top one, 4 times 3 is 12. 1 times 3 is 3. So I bring that straight across. So 3/12 is the equivalent of 1/4. On the bottom one, I have 1/3 times 4/4. 1 times 4 is 4. 3 times 4 is 12. 4/12 is the equivalent of 1/3. Now that I have those, it's a common denominator, right? So now I can just work those like I did. What is 3 plus 4? 3 plus 4 is 7. I bring the 12 down. Is there anything to divide it by? There's not. So that's my final answer there as 7/12. Okay, so hopefully you kind of see how that works. On this next one here, if you want to pause it and work it out yourself, please do. You can pause it and then I will talk you through it. But this is the next one. Give yourself a couple seconds to do it. All right, hopefully you had a chance to do that. The first thing we have to do is make equivalent fractions so we can get a common denominator for both of them. I look at 3 and 6. I know that 3 goes into 6, so 6 would be a common denominator. So what do I have to multiply each of them to get to that number? I multiply 2/3 by 2/2. I multiply 1/6 by 1/1. And you may say, dude, why didn't you just bring the number across 1/6? You can do that, but what I want you to start doing in math is to follow a pattern. If I follow a pattern, I'm going to do it the same way every way, no matter what. I just get in a routine and I can do it. That's what I want to do here, is just follow my routine. So as I multiply those over, 2 times 2 is 4, 3 times 2 is 6, 1 times 1 is 1, 6 times 1 is 6. The reason I say each of those, even the 1 times 1 is 1, again, it's a pattern. I want to follow it the same way every time. That way it doesn't matter what numbers are in there. I can do it the same way every single time that I need to. All right, so now I have 4/6 over 1/6, or 4/6 plus 1/6, and that gives me 5/6. Can it be reduced? No, it cannot. That is my final answer. All right, so let's look at the next one. Again, if you're watching this on YouTube and you want to work it out, hit pause, work it out, and see what you get. You have to start first. What can we do to make these fractions equivalent? And we got to find a common denominator. So what I did, I multiplied the top by 3/3 and the bottom by 8/8 because that will give me an equivalent fraction of 24. All right, so to do that, 3 times 3 is 9, 8 times 3 is 24, 2 times 8 is 16, and 3 times 8 is 24. So I have my numbers there. Now I'm going to add them together. What's 9 plus 16? 9 plus 16 is 25 over 24. Uh-oh, something's wrong. How can my top number be bigger than my bottom number? Think about that for a second. What has happened here? If you're on YouTube, you can hit pause and try to see if we messed up. You can try to think about it and go, well, what do we do there? Think about if you had a pizza party and each pizza was cut into 10 pieces and there was cheese, pepperoni, sausage, all the different kinds of pizzas. And as you're cleaning up at the end of the night, you had 15 pizza boxes. Well, as you start gathering the pieces up, if you are like my family, usually each pizza people eat a little bit out of. So instead of having 3 pizza boxes in the fridge, we'll just compile it into 1 or 2 boxes. That's what's happening here. We have 24 pieces make a whole of this fraction, and we just happen to have 25 pieces. It's like saying a whole pizza is 24 pieces, and when we put them all back together, we had 1 whole box of pizza, but then we had 1 extra piece hanging out. All right, because we had 25 instead of 24. So let's look at what we need to do to reduce this fraction. What this is called an improper fraction. And again, if you want to draw your notes out on your paper and put all this down, this is a good way to do it. I try to make all capital letters and underline anytime there's a good vocabulary word for you there. But this is an improper fraction. The numerator is larger than the denominator. 25 is bigger than 24. So the numerator, bigger than the denominator. That's what an improper fraction is. So anytime you see that the top number is bigger than the bottom number, that's an improper fraction. All right, so it's important to know and recognize when you see that. Sometimes people see it and go, oh, I must have messed up. No, it's just an improper fraction and there's a way to reduce it. And we're going to talk about what that step is. So to reduce that improper fraction, remember fractions are division, right? So we're going to divide the denominator into the numerator. 24 is going to be divided into 25. So as you see there, there's that little thing, and I'll do the animation again for you. We divide 24 into 25. And how many times 24 goes into 25? It goes one time. All right, and this is exactly what you're seeing on the screen here is how I write this out every time I'm working these problems. Off to the side, I write the 1 because I know 24 goes into 25 one time with 1 left over, because 24, if you take it from 25, you're left with 1. So I put that 1 on the top, and then it's out of, and I put out of 25. I apologize. I did all this work to do that, and I have it messed up. That should be a 24. Hold on one second. All right, we're back. I went back and fixed it with 1 left over out of 24, because 24 makes the whole, and that's how much that it comes out to be. All right, so that's the steps that you're going to follow every time you're reducing a fraction. If it's an improper fraction, you divide the denominator into the numerator, then you subtract how many is the difference between that, and then you always put it as a fraction over however many the whole number is. Now that's what we call a mixed number, because it's mixed. It's a whole number and a fraction mixed together. All right, we'll talk more about mixed numbers in our next lesson, but I still wanted you to be able to see that. All right, so now let's reduce these improper fractions. You have 2 improper fractions. We need to convert them to mixed numbers. If you are watching this and you want to pause it, just hit pause, work them out real quick, and then press play and we'll go over them. So the first thing you got to do, how many times will 7 go into 15? We divide the numerator into the denominator, or the denominator into the numerator. 7 goes into 15 2 times. How much is left over? There's 1 left over out of, and I did it again. This was really late when I was working on this last night. All right, so we're back, and 7 goes into 15 2 times with 1 left over out of 7. All right, so that gives us our different parts there. All right, now on the next one, we have 26 over 3. 3 goes into 26 8 times. That makes 3 times 8 is 24. That leaves us with 2 left over. And again, I put the wrong one there. I have really got to. All right, so we have 3 goes into 26 8 times. That's 24. It has 2 left over out of 3. So that would be the reduction of that one. That's how we would reduce that improper fraction to a mixed number. Now, on these, you can pause these, add these fractions, and reduce. Take a couple seconds. And here we are. So 4/5 and 5/6, we know we need a common denominator. For that one, it's going to be 30. So I got to multiply 4/5 times 6 over 6. That gives me 24 over 30. I got to multiply 5/6 by 5 over 5, which gives me 25 over 30. When I add those together, that gives me 49 over 30. 30 goes into 49 one time with 19 left over out of 30. So that would be the full answer to that one. And then for the next problem, 5/12 plus 7/8. The 2 over 2 is what would go into that one. That would get it to 24. 3 over 3 would get 7/8 to 24. So our denominator again is 24. That's going to be 10 24ths, and that is going to be 21 24ths. When I subtract, I cannot, or I'm adding, I'm not subtracting, I apologize. So that would give me 31 24ths. And as I reduce that, 24 goes into 31 one time with, 7 left out of 24. And that cannot be reduced. All right, so next time we will do more adding and subtracting with mixed numbers. That's where we're going to add in some of the mixed numbers. If you want more practice with this, if you would like to reduce, add, get into that, go to Khan Academy. They give you plenty of reducing, adding, and other things that you could work on there, and it'll be more of what we're going to be doing in the next couple of weeks as well. See you next week for Live with Andrew. Look for this lesson on YouTube later today. You've found this on YouTube already. Thank you for going. Please subscribe. Share the page with other people that you know need to work on stuff. It's a good way to kind of get a little extra practice and to get some of that instruction. If you have any questions or you have anything you need to talk to us about, please feel free to email. We would be more than glad to help you out. Hope you're having a great day, and we will see you next time.